In 1995, philosopher David Chalmers gave a name to a problem that neuroscience, for all its massive advancements, still hasn't solved. He famously called it the hard problem of consciousness. Well, here we are nearly 30 years later. Today, we're diving straight into this 3-decade-old mystery to introduce a brand new, highly intriguing, and entirely falsifiable proposed solution. Welcome to this explainer. Over the next few minutes, we're going to logically unpack a fascinating framework called the Neuroscience Theory of Consciousness, or NTC. This is essentially a structural solution to the hard problem. So whether you're a student, a philosopher, or a working neuroscientist, you're going to want to stick around because this is a truly groundbreaking way to look at the brain. Here's our roadmap for today. We're going to take a deeply methodical approach, starting with a clear definition of the hard problem, looking at why existing theories fall short, unveiling NTC's core answer, and wrapping up with how scientists can test this thing in the real world, along with what we still don't know. Let's get to it.
Section 1. The hard problem. Let's make sure we're all on the same page and define the ultimate mystery.
You see, neuroscience is actually incredibly good at solving what we call the easy problems, things like attention, memory, perception. Science can hook you up to a machine and tell you exactly which neurons are firing when you see a bright red apple. But the hard problem, it asks a wildly different question. It asks, why does any of that physical, biological processing give rise to the actual subjective experience of redness? Neuroscience is fantastic at mapping the information processing happening in the dark void of the skull, but it struggles big time to explain why those physical processes actually feel like anything at all from the inside. Which brings us to Section 2. Existing theories fall short. Specifically, we need to talk about GNWT and IIT. To really get why NTC is such a game changer, we have to look at the current heavyweights in the field. First up, Global Neural Workspace Theory, or GNWT. This brilliantly explains access, basically how information becomes globally available across the brain. But it misses the inside view. It doesn't explain what that access actually feels like. Then we have Integrated Information Theory, or IIT. IIT explains experiential richness using a mathematical measure called phi. But its Achilles heel is a highly contested metaphysical commitment that phi literally is consciousness. So both offer massive clues, right? But both leave a gaping experiential hole. And that is exactly where NTC comes in. It bridges that gap. Instead of tossing out these existing theories, NTC boldly proposes the missing puzzle piece that snaps them together. It adopts GNWT's global ignition architecture as the physical access mechanism. It keeps IIT's phi as a way to measure phenomenal richness. But here's the kicker. It adds a constitutive account of what that globally ignited integrated activity actually is when experienced from within. It's like taking two halves of a torn map and finally finding the tape that connects them. All right, let's dive into Section 3, NTC's core answer, the structural solution. Think about this for a second. If you ask a frequency meter to show you a picture, it won't have one. Not because the picture doesn't exist, but because that instrument was simply never built to show it. This analogy perfectly hits the nail on the head for what NTC calls a category mistake. We're constantly expecting third-person neuroscience measurements, like an fMRI scan or an EEG readout, to physically show us first-person experience. But those tools only measure physical organization by design. Asking why a brain scan doesn't itself contain the experience of a memory is literally like asking a frequency meter to show you a photograph. It's just a wrong tool for the job. To fix this category mistake, NTC introduces the fundamental postulate. It states that consciousness is a fundamental biological property of globally integrated, reflexively self-modeling neural activity, whose intrinsic nature is to constitute experiential value. Okay, what does that mean in plain English? Basically, when the brain integrates information and models itself, the system inherently has an experience. Just like physics postulates that mass generates gravity, right? Without trying to derive gravity from something even more basic, NTC establishes this biological, experiential property as fundamental. It just is. Building right on top of that, we have the epistemic principle. This tells us that you never ever encounter neural activity directly. Think about it. Even when a brilliant neuroscientist is staring right at a patient's brain scan, their access to that physical reality is entirely built by their own visual experience, their own visual cortex. This is a massive reality check. It reminds us that while physical reality is completely mind-independent, our scientific access to it is always 100% experiential. We're always looking at the world from the inside out. So, how do all these pieces actually fit together? NTC lays it out in a logical three-step progression. Step 1, intrinsic phenomenality. Step 2, neural architecture organizes it. And step 3, a specific experience is disclosed. You see, NTC argues that neural architecture doesn't just manufacture experience out of thin air. Instead, it takes an already phenomenal biological system and organizes it into a specific form. So your auditory architecture organizes that baseline phenomenality into the sound of music. Your visual architecture organizes it into the sight of a sunset. The architecture doesn't create the experience, it just specifies the flavor of the experience you're having. Moving on to section 4, testing the hypotheses. Let's talk about honest falsifiability. Because look, a scientific proposal is only as good as its ability to be proven wrong, right? So let's look at exactly how we could falsify NTC. The theory makes some very concrete predictions. First, there should be a measurable PCI, that's a specific index of brain complexity, that accurately tracks consciousness. Second, global ignition must be absolutely necessary for all experience. Third, we should see architecture modality coupling. That means if you systematically alter the architecture, you systematically alter the modality of the experience. Fourth, we'd expect functional reassignment and cross-modal plasticity. Like when the brain repurposes sensory architecture after early blindness, the subjective experience should track the new function. And finally, an organization versus phenomenality dissociation, meaning damaging sensory architecture should degrade the organization of the experience, like getting blurred vision, but not erase experience entirely as a category. Now, I want to be perfectly clear here. None of these have been experimentally confirmed just yet. This is a proposed theory loaded with rigorous, testable hypotheses, just waiting for real-world data. Which naturally leads us to section 5. What remains unanswered? Let's make sure we're not overclaiming. To earn our trust, a theory has to lay all its cards on the table, and NTC is very upfront about its limits. First off, the exact mathematical mapping from neural geometry to phenomenal quality, that's merely an exploratory illustrative formalism right now. It is not fully derived. Second, like I mentioned, no experiments have been run. The predictions are out there, but data collection hasn't even started. And third, the boundary conditions remain entirely unknown. What specific species, what developmental stages, or even what artificial intelligence systems might cross the threshold into consciousness? We just don't know yet. Those are massive empirical questions. I love the transparency here because a theory that hides its blind spots doesn't deserve to be believed. Solving that mathematical mapping and finding those boundaries are huge, exciting future undertakings. And that brings us to our final stop, Section 6, an invitation to collaborate, calling the scientific community. So the ultimate question is, can you break this theory? We've got a structural, fully falsifiable proposal sitting right here on the table. The author of NTC is actively looking for collaborators. We're talking neuroscientists with access to PCI, fMRI, EEG, or cross-modal plasticity paradigms to help design the actual experiments. We are inviting all the brilliant minds watching this explainer to dig into the full paper, design the tests, run the predictions, and try your absolute hardest to break it. Because if this framework actually withstands the pressure, we might literally be looking at the foundation for finally solving the hard problem of consciousness. Which leaves us with one incredibly provocative thought. If consciousness really is just biology structuralized, how close are we to building an artificial mind that doesn't just calculate, but actually feels?